Hi guys, I'm Vivi from PSC team, and today I'm going to talk about Mopro, and which can help you to build a mobile native app for iOS and Android. Yeah, so what is Mopro? Mopro stands for Mobile Prover. So our goal is to help developers to build a mobile app, and we also want to develop a robust ecosystem for privacy-preserving mobile apps. Yeah, and there's a link to our documentation, zkmopro.org. Yeah, and what we provide, the first one is the Rust wrappers for supporting different proving systems, because for now there are so many proving systems are written in Rust. So, but some of them are not, like Circom and like Noir backend is written in C++, and we provide Rust wrappers for these proving systems. And we also help you to generate cross-platform bindings with the same Rust code. So you can write one Rust code for iOS, Android, and Watson. And we also provide CLI tools for developers. So it is inspired by Foundry. So Foundry has so many different functions for developers to easily develop with Ethereum. And we also have starter templates to quick start the project. So we also provide some templates for Noir, so you can easily getting started with that template. Yeah, and we also have a management for mobile SDK to easily let you integrate your Rust code to mobile native. Yeah, so here we show the example how we use Rust wrappers. So because right now the Noir doesn't support Noir.rs, so we build the binaries from C++, and we use the Rust to link to that library and define the interface to use this library. For example, we use the binary and have an interface called prove ultra honk, and then you can send inputs and witness and the circuit inside this function, and it will execute the prove ultra honk exactly like the C++ code does. Yeah, so we have these Rust wrappers for prover and verifier. So you can just write whatever you want in Rust, and then have a prove and verify function inside. So you don't have to go out to CLI and send back the results from the CLI, or you go to the browser and then switch different platforms. Yeah, and the benefit for writing Rust is that comparing to this is the libraries from ZK Passporting. They develop both Swift and Kotlin code to wrap up the Noir backend. Yeah, and you can see there are some different implementation in Swift and Kotlin. So with Noir.rs, you don't have to maintain these two platform-specific code. You just have a Rust code, and then you can output the FFI with UniFFI, and you can use them in Swift and Kotlin. So you don't have to maintain this code. Yeah, so here we introduce how we can get started with Mopro. So we provide the CLI, so you can just use cargo install Mopro CLI. Yeah, if you have installed Rust, yeah, and you can create a new Mopro project, use Mopro init. And here's how we define the interface you want to use in mobile native. So here is the ZK email example. If we want to have a ZK email circuit proof, and you can write the ZK email circuit in this function, and define the your input should be SRS pass and the input of the circuit. And then you can run Mopro build to build the bindings for your platform. For example, you can choose iOS and Android. Yeah, if later we have more time, I can demo this. And yeah, if you want to update your bindings, you run the Mopro update again to update the bindings you used in iOS and Android. Yeah, and this is how you open the example app. For example, open iOS app, open Android app, and React Native, and also Flutter. Yeah, and this is the example view that if you are using Flutter, and then you can have a same code base and have two platform front end, like iOS and Android. Yeah, and for more advanced use, you can import any Rust creds. For example, you can just import semaphore RS and, for example, generate an identity for the semaphore protocol. Yeah, but here, right now the semaphore RS implementation are also in for growth testing, so they haven't had a Noir backend semaphore Rust cred. So maybe it also is a good idea to implement this. Yeah, so if you want to customize your function, and then you need to run Mopro build again and run Mopro update again. And since last Noir hack, I and my team members also built Stealth nodes for mobile in the Noir hack. And maybe it's also a good starter for you to play with Noir mobile app. So we integrate the Google OAuth in this app, and you can log in with Google OAuth and then get the JWT, and then use Noir circuits to prove the JWTs from certain organization, and then you can publish the post on the Stealth nodes platform. Yeah, and we use exactly the same backend as the Stealth nodes. Yeah, but we also support the Markdown in our mobile native implementation, which is not supported in the website version. Yeah, so it is very cool project to hack. And I also want to share the benchmark results. Yeah, so we benchmarked several circuits. And actually, in most cases, the Noir performs better than Circom, yeah, here's not a comparison between different proving systems. But so in this table, you can see the iOS and Android performs much better than the browser. So it can speed up to 10 times faster in catch up to 56, and in mobile, in the app Stealth nodes, it also speeds up 10 times faster than browser. Yeah, here's the benchmark. Yeah, for browser, it takes me 37 seconds to prove, but it also only take 2 and 4 seconds in mobile. Yeah. Yeah, so if you build a mobile app, you can have a much better performance than if you have web app. Let me check how much time. Oh, I have so much time left.
Can I ask
yeah.
the Stealth nodes benchmark?
Mm-hmm.
The browser, is the browser runs on iPhone, or the browser
Actually,
also runs on Mac?
Yeah, actually the browser runs on Mac.
Oh.
Yeah, but actually I should like compare it between like iPhone and
I see.
yeah.
So even though the hardware might be a lot stronger
Yeah.
compared with iPhone, but inside the browsing
Yeah.
performance is like 37 seconds.
Yeah.
Oh. See.
But actually my Mac is M1 Mac Pro, so it is like older than my iPhone.
So from into those platforms, you're recalling the movement from a browser, but where it says browser, you're actually performing it within the browser sandbox, and with Android and iPhone, then it'll be calling out to bind into a native function, right?
I'm sorry.
So with each of those four benchmarks, you're calling the true operation from a browser, you're pressing a button in the browser to start proving. But whereas where it says browser, that proving will happen within the browser sandbox, within the JavaScript that runs in the browser. But the Android and iPhone, they'll be calling out to native objects.
Yeah, right.
A desktop or?
Yeah, so yeah, the desktop is just writing like Noir CLI to generate proofs for. Yeah.
Is it because the availability of binaries that makes it much faster in mobile?
I think the browser, because if you use the Watson and yeah, so yeah, it is cannot have the much capacity like in native. Yeah, because it has to run among all the devices in the browser, so it cannot achieve the performance like in native. Yeah. Any other questions so far? Yeah, and I think I can demo a little bit about how to use the CLI. Yeah, so because I already installed Mopro, so I can use Mopro init, and then I can name the project name, for example, NoirCon2 Mopro, and you can pick one of the proving system or adapters you want to use. So here if we choose Noir, and it just create a template for you, so you can go to the directory and open this project. Oh yeah, so it will be a Rust project, so we can generate bindings from the Rust code. And actually, we have already write the generate Noir proof in this Mopro FFI macro. So like in the test, you can just use the generate Noir proof in your code. And here's the example how you can customize your function. For example, it's the hello world, but you can also import Rust, semaphore Rust, or any other creds you want to use. And then you can run Mopro build, but actually it takes several times. So, yeah, but it shows that you can like select the platform you want to build for. For example, you only have like iOS device, you can only build for iOS, and choose the one of the architecture. So this is for device, and it's for like M1 series simulator, and this is for Intel chips simulator. So for example, I choose M series simulator, and it starts building, and it takes some time. Yeah, so if you don't want to like build again and test on mobile native, you can just write the Rust code to check the like bindings and the function works correctly in Rust, and then you go to mobile native. Oh, and I can share like for Stealth node, because it has to process the JWT. So actually we write a lot of functions to process the JWT file, like proof JWT. And yeah, we have to generate inputs and have a like ephemeral kit in this protocol. And we have to, for example, like use ED 255.119 to like generate a key pair, something like that. And then we use the bindings in the iOS and Android. Yeah, so we can do a lot of things in Rust, and then like send messages, something like that. And we can just use these functions in mobile native. So you don't have to worry about there's no implementation for like Swift or Kotlin about this function. Yeah. Oh, and yeah, I just turned on the Stealth Note app, so you can try it on simulator. Yeah, for example, you want to verify if the one have submit a valid proof, something like that, and you can post. Oh, and we also implement the like internal. So if you have like psc.dev domain, you can post in this internal channel. Yeah, for example, hello, NoirCon2, and publish post. Yeah. Something like that.
One question is like in your experience, like how's the DevX when building mobile app compared to web app?
Ah,
Because
actually,
web app also have a lot of like supports and like rich ecosystem. But is there any things that you feel better when like doing mobile?
actually, because right now we use AI a lot, so actually for now, I think it's almost the same, because you just ask AI to like write these widgets or like write this front end for me, and then AI can do everything for you. And then the AI capacity is actually, I think, almost the same for building mobile app and web apps. So I think it also lowered the like difficulty for people if they don't have any experience in building mobile app. Yeah, like this front end, I also asked AI to help me to build it. Yeah, and you can see the result is very, very good.
I can imagine that if you want to add like take a photo and like
Yeah.
send it to
Yeah.
Signal, with mobile it's much more easier compared to like using laptop. Yeah. We'll also like some GPS. Seriously,
Yeah.
would be more easier
Yeah.
to do that on mobile compared to web app.
Yeah, you mentioned a good point, because I think developing a mobile app has many advantages for using the mobile hardware. Like, for example, the GPS and camera and gallery and like biometrics, like your fingerprint or your face ID, something like that. And also integrating the Google Auth is also easier, because they are, like for Flutter, they have really complete like Google Auth package and very easy to integrate in your mobile app. Yeah, I haven't showed that. For example, I log out and then I log in with Google again, and it's just like any other mobile app you use in your daily life, and then you choose your account. So it's all within this mobile app. You don't have to redirect to any other places. Yeah, log in. No. What happened? I don't know. Maybe the internet. Oh no. Okay, I will try this later. But actually, for this, I published on like Android store. I published the Android APK, and you can test it with Google App Store, iOS App Store. So if you are interested, you can download this app. Yeah. Oh. Yeah, so the GitHub link is here. If you want to play with it, you can go to this link. Yeah, so this is my talk today, and my Telegram and GitHub is Vivian Jeng. Yeah, so welcome to reach out to me. Any other question?